Okay, let's continue on the linear first order differential equation, solving that using the integrating factor. Let's take another example. Y prime minus y equal 2 multiplied by e to the power 4x. And the question is asking us to solve this linear equation using the integrating factor. As we said before, the linear first order differential equation has a general form, which is y prime plus p of x y equal q of x. Now firstly we want to identify the p of x and q of x in our equation. So p of x is usually happens to be the coefficient of the y, and the q of x is the right hand side of the equation. So p of x in this case equal -1, and q of x equal 2 multiplied by e to the power 4x. Next step, we want to find the integrating factor. As we said before, integrating factor can be represented as g of x equal e to the power of the integration of p of x dx. In this case, p of x is -1, so the integration factor is e to the power of -1 dx, which equals to e to the power of -x. Now we take the integrating factor, and so the integrating factor in here, we multiply it by the main equation. Let's call it equation number 1. So e to the -x multiplied by equation number 1 will give us y prime e to the power -x minus y e to the power -x equal 2 multiplied by e to the power 4x multiplied by e to the power -x. So we can notice in here the integration factor being multiplied by each part of the equation. Now taking a closer look to the left hand side of the equation, this represents the multiplication of y with the integration factor being derived. So it is y multiplied by e to the power -x prime equal the right hand side of the equation 2 multiplied by e to the power of 4x minus x. So when we multiply e to the power 4x by e to the power -x, it's basically you just make addition to the powers, which is 4x plus the -x, which gives us e to the power 3x. Next step, we take the integration of both sides of the equation. So the left side of the equation becomes e to the power of -x, we get rid of the derivative, equal 2 divided by 3 e to the power 3x plus constant. Now keeping y alone on the left hand side of the equation can be achieved by dividing both sides of the equation on e to the power minus x. So we get y equal 2 divided by 3 e to the power 3x plus c e to the power x. And that's our solution. Sometimes the question could be slightly different. He will give you the equation asking you to solve that first order differential equation using the integrating factor, but he provide you with the initial value, which is called an initial value problem. So you need to find the values of your solution. In this case, assuming that the question gave us the y of 0 equal minus 3, you basically follow the same procedure to solve your problem and finding your y as the ultimate solution. So this is your ultimate solution. Now you start to use the initial value given to you in the starting of the question. How you're gonna solve it? You just basically substitute the values of x and y in the final solution. So in this case, x is 0 and y equal minus 3. So you can say here, so from here, this is basically the y is an embedded y of x. So instead of y of x, we can say y of 0, since the value of x is 0, that's what's given to us in the starting of the question. Y of 0 equal 2 divided by 3 e to the power of 3 by 0, which is e to the power of 0, plus c multiplied by e to the power of 0. As we know, e to the power of 0 is 1, so we can put that as 1, and the y of 0 equals minus 3, as we can see up here. Doing that, we can find that minus 3 equal 2 divided by 3 plus c. So we are trying to find the constant in our main solution, in our final solution. So we need to know the value of c by compensating the initial value given to us in the question. We can find that the value of c equals to minus 3 minus 2 divided by 3, which equals to minus 11 over 3. So your final ultimate solution of the linear first order differential equation is y equal 2 divided by 3 e to the power of 3x minus 11 divided by 3 e to the power x. And this is the grand solution of the first equation. Thank you.